what's called simplifying. Of course, I'm not sure, maybe one of my videos does cover this, but I'll just cover it real quick just for the heck of it, because I send the copy of the archive to my lecture classes too, and they've been liking them, some of them. They've been saying, Young, unlike you in class, I can rewind this, stop it in slow motion and so forth, so this is good. Now, there's a couple ways you can simplify complex fractions, all right? So I'm going to go ahead and give you an example of one, and it might scare you at first, I don't know. And I hope not, but let's look at one here. I'm going to take the first example of the complex fraction. I'm going to give you 5 minus 3x. Oh, I'm sorry, let me start over here, my bad. 5 minus 3 over x divided by x plus 2 over x. Now, complex fractions are fractions over fractions over fractions. All right? So there's a couple ways to do it. There's the easy way and the hard way, but I'm going to go ahead and type some notes here that will cover all of them. So I'm going to put to simplify any complex fraction and then go from there. So here's how to do it. We're going to multiply both top and bottom of complex fraction through by the LCD, and that's huge in Chapter 6, the LCD. It's like winning 90% of the battle in 6.2 here, and then 6.5 if you can simplify complex fractions. Multiply both top and bottom of complex fraction through by the LCD of, and I think I want to put this in a different color here. Hang on here. I'm trying to line this up. Both top and bottom. So this is my first time I've tried some colors here. I'm trying all kinds of new things tonight. Okay, we'll see if this sounds good. To simplify any complex fraction, this is the easy way. There's another way I can show you as well, but it'll take more time. Multiply both top and bottom of the complex fraction through by the LCD of both top and bottom of the complex fraction. Now, Young, what do I mean by that? Well, what I mean is if I circle this top here, what would the LCD be? Well, there's only one denominator in this, and that's x. All right? Also, if I circle the bottom, what's the LCD of that? Again, you see, hopefully, it is x. So what we're going to do to simplify the fractions, which means get rid of fractions over fractions, because you know that doesn't sound good in math, we're going to multiply by the LCD of both top and bottom, which is x. And you're allowed to do that, remember. If they're fractions, you're allowed to multiply top and bottom by the same thing. It's a legal move. All right, so multiplying the x's through here, 5 times x, and then when the x hits that fraction, it's going out. And in the bottom, we're going to have some similar action happening. Watch what happens here. We're going to get in the numerator 5x minus 3, and in the denominator, x squared plus 2. So we have taken all of those fractions over fractions and simplified them into a single fraction. And that's what we're going to do for the next 4 or 5 examples in section 6.3. All right, let's try a few more here. And I'm going to go ahead and type 6.3 here, just so people, they come chiming in, will know where we're at here tonight. And let me take one that has a little more interest here. I'm going to take, and this is similar to the last one we just did, and we're going to work on some more sophisticated ones as well. 2 plus 1 over x divided by 4x minus 1 over x. So again, notice the common denominator of both top and bottom would be x again. So I'm just going to go ahead and multiply through the top and bottom by x. And I'll use some colors on this one. So distributing, we're going to get 2 times x is 2x minus x times 1 over x is 1. Now, if you want to, when you're distributing, you can take that x, and when you multiply it and hit this fraction, you can call it x over 1 times 1 over x. And you can see the x's are going to cancel to give you that 1. All right, divided by 4x times x would give us 4x squared minus 1. And that's the answer, right? In my lecture classes know when I say that, it seldom is. Because you should recognize something in the denominator of this fraction. So this goes back to 6-1 on these complex fractions. I have sensed or see the difference of 2 perfect squares down here. So we can reduce this fraction by factoring the squares into 2x plus 1 times 2x minus 1, which of course we can check by FOILing or multiplying there. And what's going to happen, and I'll get some colors out here, the 2x minus 1s are going to cancel, leaving us with 1 over 2x plus 1 as the final answer. So when you simplify these fractions over fractions over fractions, you are simply trying to get down to one fraction, one number, and have it all simplified and so forth. All right, so let me go ahead and clear this slide, and I will put more section 6.3 examples. Now remember, the rest of the examples in 6, you can go right to my website that I mentioned earlier in the chat, and I mean, there are just tons of lessons you can watch if you missed anything in chapter 6 there, or you just want to review some stuff. All right, now I'm going to pick a little bit more of a beastie looking one here, and this might scare some of you, so don't panic. And we're going to say that we've got x plus 3 over x squared minus 9 divided by 1 plus 1 over x minus 3. So that looks even more beastie than the first couple. Now again, notice in the numerator that I see the difference of 2 perfect squares in the denominator. So this fraction in the top, I'm going to go ahead and take real quick and write x plus 3 over the difference of squares factors, and man, they will just hit you with this time and time again, x plus 3, x minus 3, and those will cancel. X plus 3 cancel out. So really, I don't know why they tried to trick us on this problem. Authors do that sometimes. They're just mean people. And we're going to end up with this simplified fraction in the top, 1 over x minus 3 divided by 1 plus 1 over x minus 3. So a little bit more challenging problem here, and we like to do that. We'll continue to challenge you here and have a little fun with these things. Now, the common denominator, do you see it in both top and bottom? That sort of sticks out like a sore thumb here. So we are going to, yes, multiply both top and bottom, as the notes have said earlier, by the LCD of x minus 3. So I'm pulling the colors out here, and what we're going to end up with is x minus 3 times 1 over x minus 3 in the top gives us 1. So I'm just distributing that through there. And you can also put a 1 under that if you want to and chop the x minus 3's. Now here's where students get in trouble on this. In the denominator, be careful. And I'm going to go with blue here. I can just go with colors in this chat like nothing. See, the x minus 3 is getting multiplied by 2 things in the denominator. It's getting multiplied by the 1, and it's getting multiplied by the 1 over x minus 3. So in the bottom, x minus 3 times 1 distributing gives us x minus 3. X minus 3 times the fraction, the x minus 3's will chop out, leaving us with plus 1. So in the bottom, you see we've got some like terms you can collect. So that complex fraction that we started with simply simplifies into 1 over x minus 2. So this thing looked really beastie starting out. Look at this thing. It has a monster complex fraction. And when we whittled it down and did some reducing, it didn't look so tough in the end, did it? All right, so let's try a few more here and show you how these things go. All right, this one might even scare you worse than the last one. So I'm going to go ahead and give you, for a next example, 2 over x plus 2 plus 6 over x plus 7. All of that divided by, I know some of you are saying, stop, Young, please, no more, I'm begging you. 4x plus 13 over x squared plus 9x plus 14. Now notice this bottom fraction here. This denominator of the denominator, I like saying that, the denominator of the denominator factors into x plus, but, and I think it would be 2, 7. And notice some commonalities in the top. So if you want to rewrite this problem, we'll just come over here and do that real quick. We'll get 2 over x plus 2 plus 6 over x plus 7 all over 4x plus 13 over x plus 2 times x plus 7. Now, do you see the LCD in both top and bottom? Yes, I think they do stick out again like a sore thumb, don't they? So here's what we're going to multiply by to clear all of these nasty fractions. And that is, did you guess it? X plus 2 times x plus 7. And if you want to, again, you can stick a 1 under there. But remember, these are fractions. Whatever you do to the bottom, you must do to the top and vice versa to get equivalent fractions. So distributing it through here, we're just going to go ahead and run it through the top first. What happens is in the first fraction, the x plus 2's go out, leaving us with 2 times x plus 7. Plus, the second fraction, the x plus 7's go out, and it leaves us with 6 times x plus 2. All over, in the denominator, the x plus 2's and the x plus 7's. Now watch this, I'm going to get a different color here. Let's go with this dark pine green, and we'll do a monster chop chop in the bottom. The whole denominators go out with the numerators, and we're left with 4x plus 13. So now we can do some distributing in the top here. So this one's got some new kicks to it. And we can end up with 2x plus 14 plus 6x plus 12 all over 4x plus 13. Now I know y'all are saying, Young, we're not done yet. We're not done yet. No, we're not. Just give me a second. You can collect like terms in the top, and you'll get 8x plus 14 and 12, I believe, is what, 26 all over 4x plus 13. And that's the answer, right? A lot of students will go, wait, but you said that earlier. Whenever you say that, it's not usually the answer. And in this case, I'm right. Because do you see there is something in the top that you must factor out? And that's back to 6.1, simplifying these rational expressions or polynomial fractions. You must always take out the common factor first. And notice what happens here, ladies and gentlemen. If you take the 2 out of the numerator, we seem to have some 4x plus 13 that can cancel or be chopped out. So I'm getting a little different color green here and reducing that. So get this. Now I'm going to go ahead and circle this in orange now. This monstrous fraction that we started out with that might have scared you to living you-know-what, it actually comes out to be the number 2. It all simplifies if you know your polynomials into that final answer. So I'm going to do one more here, and I'm going to stop the archive. And of course, I'm going to hang out until 8 in case anyone comes for help. But I mean, in this class, you've got so much help. You've got videos, you've got lecture notes in Angel. I mean, when I was a student, I would have killed for some of the things y'all have. I really would have. when I used to go to school barefoot, walk 5 miles in the snow. Probably heard that from your parents, huh? All right, let me find one more really good one here before I sign off, and that should be hopefully enough examples. I'm going to try to sneak something in from the early part of Chapter 5, some exponential rules, and blend it in with Chapter 6. I just like to take things and blend it sometimes in the old young blender. So I'm going to take this creature, a to the negative first power. Oh, we haven't seen those in a while. See, but the next test is on both Chapters 5 and 6. So you must be able to put lots of concepts together. And if you think it's bad now, wait till you get to college algebra. It'll be real fun then. All right, so I am just copying this beastly looking problem here with all these negative exponents. And you know, this is really like the problems we've been doing the last 15, 20 minutes. They're just in disguise. You must remember that power rule number 4 that goes back to your power rule handouts. A to the negative first power is simply 1 over a. Now, you have to be careful on the second one, because remember, anything with a negative exponent, if you bring it down, it becomes positive in the denominator. The second fraction, notice that the 2 has a positive power. It's the a to the negative 2 I'm going to bring down, and it's going to become positive in the denominator. Okay, all over 2 over a in the denominator. Again, the negative power only affecting the a and not the 2. But, and I picked this example on purpose because it looked really good. I'll probably work some of these in my lecture classes tomorrow. Notice the whole 2a goes in the denominator because it's in parentheses to the negative first power. So there is some great Chapter 5 review there, 5.1, 5.2. Now, to simplify this and get rid of all these fractions, what is the LCD of those denominators? You will need a 2 and how many a's? The most number of a's in all of those is 2. So the LCD you must attack with is 2a squared. And if you do it to the bottom and the top, you must do it the vice versa. And again, if you want to, you could put a 1 under there. And since these are fractions, let's just take the 2a squared and write it next to this other fraction over here too, because then when we chop, we're going to see some stuff happening. All right, so a in the first fraction goes into 2a squared 2a times. And the second one, the a squares cancel out. So do you see what's left? I tried to use pretty colors here. In the numerator is going to be 2a plus 4. Similarly, in the bottom, we're going to chop an a here with an a squared, and that's going to give us 2a. Now, don't chop the 2 on this one here because it doesn't chop there. Now, notice, and then over here, we're going to chop the 2a into the 2a squared, leaving us with an a. So the denominator, when we run the 2a squared through, is going to give us 4a plus, let's see here, a. If I did that right. I think I did that right. All right. So I hope everyone's following along here. Now, that's the answer, right? No, young. You can maybe see, well, I see a 2 will come out of that top, and that would be a good thing to see. And in the denominator, you can collect like terms. But is anything going to chop or cancel out here? No, there are no common factors. You can't cancel 2 and 5 out. They're not the same. You can't cancel a to a plus 2. They're not the same. So here again, we have one of these nasty, beastly fractions. And I'll go ahead and circle this up here. And let me go with a violet color here. So this beastie looking thing here with negative exponents simplified into something sort of nice. All right, so I think I've covered 6.3 well. I also have the long division, section 6.4 on my videos on my website. So let me see if I can take you back there real quick. I just cleared the whiteboard. Oh, I shrunk that. I've never done that before. I kind of like it though. It looks kind of cool. I wonder if that's going to show up when I save this archive here. Well, we'll have to see. So let me just take you back to my web page one more time. And I'm going to try to show this in the same content screen here. And again, if that box is in your way, you can get rid of it. And then if you just scroll down, I'm just going to go to the videos there where it says Empowering Introductory Algebra Videos. For long division, I'm not sure if I mentioned this earlier, you can start with videos 13 and 14. And also, even going back to chapter 5, if you want to see some more examples on factoring and so forth, you know, I've got a bunch of videos there, 15, 16, 17, 18 in chapter 5 that will help you with factoring as well. So remember, online students, you get extra points for doing this, checking out these videos, commenting in Angel, and I give my lecture students other ways to get extra credit, so I try to give everybody a little bit of extra credit when I get a chance. So that pretty much concludes Chapter 6. So this is Bob Young signing off, and let me know if I can help you in any way as we progress.